Good evening or morning, as the case may be. I'm looking at the chat over here. I see a couple of people arriving. Welcome. We'll give you a few minutes for people to arrive. If you're in chat, let me know where you are, where you're watching from. Northern California, Zachary. Where exactly are you in Northern California? I grew up there. Salinas. Awesome. Glad to have you here. The question, are we reviewing what we went over last time? Only a little bit. We're going to look at a lot of the same principles relating to JavaScript, but we're going to look at them from within a totally different way of executing JavaScript code that many of you may have already heard of or be familiar with, called Node. So we'll learn more about JavaScript. We'll also get familiarity with how to run your JavaScript code in a whole separate place than the browser. Excellent. DMAC, where are you watching from? DMAC 93065. That actually looks like a California zip code. All right, let's get started. We have whoever we have here. I'm glad you guys showed up, and we'll get you some valuable data. First of all, just respond in the chat if you would. Are you familiar with Node at all? Just yes or no in the chat. Are you familiar with Node and what Node is? Excellent. Oh, Long Beach. Excellent. Glad you're here. No, sort of. Okay, good. Excellent. All right. So last class on Saturday, and by the way, these are just off the cuff classes that I'm doing just to put something out there and give people some help with JavaScript. If you've been paying attention to my social media, you probably know, or if you don't, you're going to hear it, that I'm starting a free code school in about a week. I'll put the launch date out on my socials. But I'm deciding on the final student body. This isn't part of that. This is just me wanting to help. And if you have any sort of JavaScript questions, any programming questions, anything in general, I want to help. Okay. So, oh, good. We have somebody from the UK. Excellent. SJW68. SJW68. Have you emailed me? Awesome. I'm very glad you made it. Man, it is early where you are, isn't it? Okay, good. So again, just to be clear, this is not part of the actual code school I'm going to run. This is just JavaScript help and talk about Node a bit. All right, so let's just figure out what Node is, first of all. The easiest way to start thinking with Node is to just think about the normal place, that we used to run JavaScript code and still do. And that's in the browser. And when I say the browser, there's lots of browsers. There's Chrome, right? There's Firefox, there's Opera, there's Safari. There's tons of different browsers. But virtually every one of them, in addition to letting you browse web pages and view the web page user interface, nearly every single one of them also provides a way for the browser to run JavaScript programs that you can ship to the browser. And that's where if we've ever learned JavaScript, ever practiced any of it, if we've used it in the world, for many years, it was just in the browser that JavaScript code would run. How did that work? Well, the browsers had what's called an execution environment. And that's just a place where code can run for a given language. Now I'm going to ask a question here of chat. Oh, hi, Nene. Excellent. I'm glad you're here. I'm going to ask a question in chat. And if you don't have the answer to that, it's totally fine. So actually, you know what? Let's have a little fun with this. I've got 3 viewers right now. How would you all like to, oh, I just jumped to 10. Okay, good. All right, we're not going to do that because it'll get too big. All right, so here's the question in chat. How many of you have written a JavaScript program as part of a web page? Give me a yes if you've done that. If you've written a JavaScript program and it was part of a web page or a website. Good, that's a 1, 2, excellent. Thank you for a repeat. A tribe called Quest 94, username of the night. That's fantastic. Okay, a no. Okay, good. All right, so good. Almost everybody has. So I was going to show this anyway, but for those of you who haven't ever done this before, the principles involved are actually pretty important to know. Good. Nene, only in console.log. Excellent. All right, so let's look at what I was working on a couple of days ago. It's a super complex website. Let's see. There we go. I think I had this under Twitch test. Nope, wasn't that. Oh, I think I grabbed AOLCC. Yeah, there it is. All right, so for those of you who aren't familiar with it, this computer program I'm using is called Visual Studio Code. You can see that at the top right here. And this is what we worked on the weekend. This is a web page you see in front of you. It's got a bunch of HTML, the markup language. But the important part here is that on this line 19, we're pointing the web page to a specific file called main.js. You can see main.js over here. And that's where I have some JavaScript. Here's a bunch of JavaScript that we worked on. By the way, someone on Twitter recommended I change the theme I use. And is this a little more readable? Give me some feedback in chat if this is more readable than what we had before. You know what would probably help is if I actually shared my screen, huh? Thank you, chat. You guys rock. Okay, so because I was talking without sharing it, this in front of you is a web page. It's got some basic HTML in it, but the important part that we're looking at is this line 19 right here, where we point to a file called main.js. Main.js has a bunch of JavaScript. Good. Thank you, Zachary. Yeah, I realized, especially like yellow on a white background, really not a good choice. But here's the point. These files are all down on my file system in a folder called Eric Demo ALCC. But when I go and actually look at the resulting file in a browser, when I look at this web page in a browser, notice how it says demo of simple web page, smaller text. Let's go ahead and run that. And I'll pull it over onto the screen. There's that web page. Now, it's super important to understand underneath the hood what just occurred. This program, which is called Chrome, we've all seen it. Chrome was told to go to this exact location in the file system and acquire this exact file and any other files in that directory. Now, that, of course, is happening on my computer. You can see it. I mean, you could literally open up the Windows Explorer down here, and we could go find these exact files. And we don't even need to do that. If we're looking at Visual Studio Code, we can see them. There they are. Here's the file, the folder, and here's the files in it. But to go back to this, Chrome, when directed to a specific web page, acquired that web page from a file system, along with every other file in there, and pulled those files into itself, into the browser itself. Now, this simulates the way a real world website would work, in that in a real world website, these files that we're looking at right here would be out on a web server somewhere. And web server sounds all fancy. It's just a big honking computer with a lot of power that can store a lot of files. The same thing happens though. Your browser on your computer sends a request for the files of the website. It says, hey, can you send me all these files? They come back to the browser and they're on your computer. So why do I stress that? Because we're writing this JavaScript code. We're storing it somewhere. In my case, it's being stored on my computer in a directory. And then when someone wants to use our website, we're sending this file to them. It's just a text file. There's no magic to this file at all. It is literally just text. However, it's text that's written in JavaScript. So what happens when this text file, because again, it's just text, what happens when this text file arrives at your user's browser? Well, that's what we see right here. In the user's browser, I'm being my own user, which is what makes this a lot of fun, right? If we right-click here and go to inspect, we can see a bunch of different tools. One of them is called sources. These are the source files used to create the web page and any other functionality. And when we click on there, we see the source files came from my local file system, and they include all three of these different files. Those files, or rather the contents in them, have been sent into the browser. But now we're talking about JavaScript. If the browser now has all of this text that was in the file system, but it's now inside the browser, inside this running browser program, well, the browser has a way to execute this. It's got a way to run this JavaScript. Now, for many of you in the class, this is a concept you're pretty familiar with. It's not what we're going to talk about in detail today. But I want to remind you of where your JavaScript actually runs. Where does it execute? You may write it on your computer for your web pages. But when it's being used by an end user, someone who's browsing to your web page, your JavaScript that you wrote is being used on the user's browser. It comes in as a text file, which is exactly what you're looking at right now on the screen. And that text file is given to a special part of the browser called the JavaScript engine. And the JavaScript engine is capable of reading these text files and converting them into machine language, which is the only thing that'll actually run on your computer. So that's all review from last weekend. I don't want to go too deep into that, but I do want to remind you of it because we're going to look at a totally different place that you can actually run JavaScript. What if you don't want to have the user's computer be doing all that work? What if, for a variety of reasons, you want your JavaScript code to run on your computer, on your server? Well, the problem wasn't until about 12, 13 years ago, there wasn't really a way to do that. The only people who had taken the time to build really, really capable execution environments for JavaScript were the people that made browsers. Internet Explorer from Microsoft, and as we mentioned before, Chrome and Firefox and Opera and Safari. Those programs have to be maintained and built. It takes a lot of work and money to keep them capable of taking in these JavaScript files and running them for all the different varieties of computers that are out there. Because remember, you might get Chrome, but you got to get the Chrome that's built for your specific computer, your operating system. That's a discussion for another day. And if you go through the boot camp or the code school, we'll cover all of that in great detail. But now let's get to the fact that there's, as of about 2009, a whole different way you can run JavaScript. And that's what Node is. So to be very precise, Node is what's called a runtime. I covered this just very briefly right at the end of the class I did on Saturday. And someone in that class did a pretty decent description of it. So I'll just tell you what a runtime is. A runtime is a system, typically, it's one or more like computer programs that you can install on a computer. And the whole job of that little program, this runtime program, is to be continually running, just sitting there waiting to be of service. Now, of service to what? It's sitting there, this runtime program is sitting there waiting to be of service to the computer programs you build in the language that runtime marries up with. There's a runtime for specific languages. Let's get a little more concrete because this is JavaScript tonight that we're talking about. Node is what's called a runtime for JavaScript. That means it's a computer program that you can install on a computer And as soon as you turn it on, it just sits there running continuously. And it's waiting to be fed JavaScript code, to be fed the text files like you see right on the screen. And just like all the different browsers are capable of, Node, this continually running program called a runtime, is capable of ingesting those text files, taking them in, and turning them into machine language that can run on the computer that it's on. And if you've ever installed Node, this is why you'll see there's lots of different versions of Node. Well, what they really are is Node for the different types of operating system and computers out there. There's one for your Macs. There's one for different, versions of the Windows operating system. There's one for, the Linux operating system, that sort of thing. Because while it may take in JavaScript, this runtime program may take in JavaScript, it has to convert it to a machine language that's specific to the exact hardware and operating system that it's on. Now, if I went over your head with a little of that, I apologize. There's a lot more under the hood there, and I'll teach all that in the 5 Live Code School. But for now, what we're looking at is just the concept that there's 2 places now that if you write a JavaScript program, it can execute. One is in the user's browser, which is what you see in front of you. And the other one we're about to demonstrate is down on someone's server. Good, so let's look at that. So first I'm going to show you a running Node application. We're going to run it and kind of bang against it and kind of see a little bit of how it works. And then I'm going to create one from scratch with you. So the one I want to go back to is something that I built a while back for a class. Let me go ahead and pull this up. All right. All right, now we got a lot going on here. I'm not going to be able to give you a tour through this whole thing, but I'm going to get it up and running and show you a few basics. So a couple of things I'm going to do, I'm just going to get them done without explaining too much, just to get this thing up and running. When we done with the little guided tour through this computer program, we'll build a basic program, a JavaScript program using Node, and then I'll get a little more explanation on things. But for now, I want to do a little step that makes sure that any of the third-party computer libraries that my program needs get installed. I use a tool called npm to do that and give it a command called install. And it's just make sure that if there's any third-party code libraries that my computer program is using, that they're up to date. It downloads them from the internet. All right, now I'm going to start my computer program. All right, so it says here down in the console, and if you have any sort of controls down at the bottom and you can't see it, I got a little console log message says server is running on port 8080, and then it's got a smiley face because why not make your computer program friendly? So I have an actual web server set up on my computer right now. It's kind of cool. I don't even have to do much to work with it or configure it. In fact, one of the cool things about this Node runtime is it's got some extras. It's not just a runtime to let you run JavaScript code. One of the big things is it also has a built-in web server, and it's a really, really good web server. That web server right now is up and running, ready to receive requests. So let's give it a request. So it says port 8080, huh? Well, let's get a browser going here. Let's go to port 8080. So localhost, that's my local server there. Port 8080, let's see what happens. Oh, look at that. I got something back. Now, I want to clarify something. That's a pretty ugly UI. That's not a very friendly user interface. But I want to, again, let you know, we're not building a website, a web page here. We're building an application, a computer program that's going to run on some server somewhere. Its job is not to create pretty user interfaces. The job of this particular program is to sit there ready and waiting for requests to come in. In this case, requests about customers and orders and products. But the job again of this program is to sit there ready and waiting for requests to come in for information about customers, orders, products, that sort of thing, and to send that information back to whoever asked for it. Typically, it would be a browser that asked for it, but it's the responsibility of the browser program to make it look all pretty. That's not what this program is that I built. This program is an example. It's called an API, or an application program interface. And it's just sitting out there, like I said, waiting for requests to come in. Well, let's give it some requests, because there's more things that can be done here besides just go to the website and get a really boring message back. To do that, I'm going to use a special program that can create web requests and send them where I want to. It's called Postman. In chat, give me a yes if you have used Postman before. Excellent. Thanks, Fire Repeat. There's a yes. Okay, now, again, I'd like to explain everything I'm doing tonight, but it would take multiple classes over a long period to be able to do so. In a nutshell, this program you see on the screen now called Postman. Oh, good, Fire Repeat. I have a good idea to run by you. Fire Repeat, for those of you who are on different platforms besides Twitch watching this, in the chat on Twitch, one of my viewers said, I'm currently learning APIs at the moment, trying to do more MERN stack stuff. MERN stands for MongoDB, or MySQL. Stands for MongoDB, Express, React, and Node. And it's a collection of 4 technologies that can be used to create really powerful applications, web applications. So I have an idea I want to run by you, if I repeat. I think I want to just do a series of these where I just go through building a MERN stack application. So, but it looks like most of you haven't used this program I have on the screen called Postman. Now, again, there's a lot of data I can give you all about what it's going to do, but here's the simplicity of it. I'm going to use this program to create a properly formatted request to be able to send over to my API. The request is just a text document. And if I send it to the right location, to the right web server, and it gets received by my computer program, then my computer program will do its work and give me information. Let's build one of these. I'm going to make a new request. I'm going to get information, and I'm going to get it from the local server. And the local server, my computer application is there on port 8080. And I believe that if I send it products, it'll get me back products. Now, I could be wrong on this, but I know how to look it up. Let's just try it. Good. So that worked. So I sent in a request to get information about products, and it sent back this giant collection here of products. You can see there's a lot of them. I think it probably gave me like 100 of them. It did, about 100, 101 of them. And every single one of these has, you know, an ID for the product, what its name is, what its price is. This is a SKU. For those of you not familiar with retail producting, I made up a word. For those of you not familiar with retail products, they have a unique identifier called a SKU. It stands for stock keeping unit, I believe. I don't want to give you wrong data. Let's see what a SKU stands for. I've got Wikipedia up on the other screen. Stock keeping unit. It is an inventory management identifier. Good. It has a description, right? You can see that right here. And this is just data about when this date information for this product was created in the database. So this worked. Now, let's look at how the application is doing that. You're about to see a bunch of JavaScript. I'll explain the parts of it that are going to matter. Okay. So this thing is running right now, my code. I want to show you how that request I sent is handled by my computer program. The first thing is that in my computer program, every single request comes in through this code, because this code tells my application to constantly listen on a specific port into my computer. Now, again, we could talk for hours. A port is like a dedicated pipe or channel into your computer, and they each have numbers. My computer application happens to be running with port 8080 open. And so my program's listening at that specific pipe or connector, saying, as soon as you send me something, if you send me a request, I'll look at it. So everything arrives here. Where does it go from there? Well, I have some more JavaScript down here. Now, again, there's lots of info on here. We're not going to go through every bit of it. Here's the parts that are really super important. On these 4 lines, I've set up what's called routing. Depending on the way I format the requests that arrived, I send my code to one of these 4 JavaScript files. Those JavaScript files are in this source folder and in this routers folder inside it. And you can see address.route, product.route from over here, customer.route, order.route. So now I'm getting farther into my computer program. Again, don't worry about the syntax on the JavaScript. There's a lot going on here. So I want you to be able to think with in sequence what's happening here. Good. So we go from these routers, and let's just look at the one I used. I used products. And in here, I'm going to route this request a little bit more even. I'm going to route the request to a specific, and now we're getting kind of familiar, a specific function. What I did was, what I sent in gets sent to this find all function. Let's look at that function. And now we're going to look at some JavaScript. Those functions are in this product controller file. Where's that? Well, it's up here in controllers, product.controller. And there should be a find all function in it. Let's look. And look, there it is. There's a find all function. Now, the syntax isn't maybe the same as what we looked at on Saturday, but it's still a function. It's called find all. It takes in parameters. One of them is called request. One of them is called response. And this is the work that gets done by the function. Now we're looking at some JavaScript. And now we can reinforce some of the basics of what we were looking at on Saturday. Now, I have a question. Now, if you were here on Saturday, maybe remember this. If not, I just want to ask. In this function that begins on line 4, and I just said it out loud, what do we call these 2 different things inside the parentheses? Go ahead and put it in chat if you remember. Those are called parameters. Good. Awesome. Thank you. 6th season or SDN. You're exactly right. Now, again, I'm not going to reinforce everything we went over on the weekend, but I do want to just call to mind for you again that the way functions are meant to be used, they're little, repeatable chunks of code, is that your main program has a path of execution, steps that it's doing one after the next after the next. When your program finds that it needs to use the code, I'm going to highlight this, inside a function, this little repeatable chunk of code. The terminology again is that the main path of execution calls your function. In this case, the main path of execution calls our find all function. Now, in the chat, does the code that called the function always have to give some information to the function? Go ahead and put your answer in chat. There's a part of your program that called the function. Do functions always require information in order to do their job? And the answer is no, they don't always require information. In this case, it does require two things, something called an REQ and something called an RES. Those have to be given to it. But many functions don't need any information to do their job. In which case, there would be a parenthesis here, but it would be empty. You can see that on the very next line. Look at line 5. We're calling a function. It's a different function because it's attached to a different object, an object called product. But it's still a function. And look, we're calling it and we didn't give it any information. So you don't necessarily need to give a function any information. How do you know whether you do or don't? You look to where the function was created. Line 4 is the beginning of declaring or creating the find all function. Everything inside here, this is all the created find all function. Now, we happen to be making use of another function called find all. That's not the one we're making at all. That's a totally different function attached to a totally different part of the program. That comes from this object right here called a product. What that happens to be is a connection to the database. That's not our find all. All right, now I just went over some stuff here is a little bit odd. So I'm going to give a moment. I've got 10 people watching this. If you have any question about what I just said, we've got the time for it. I know you can't do voice, but in text, in the chat, if you have a question about what I just said, if it didn't make sense, if you want more, just tell me or ask me in chat. I can wait. Okay, good. Excellent. All right. Now, I want to see this in operation. I want to see this thing running. Oh, good. Kind of related. I seem to be a bit confused as to why sometimes you would use async and sometimes you just use a then catch. You know what? And he says, now I know that sounds like it could be quite a heavy answer, LOL. If I repeat, that's actually a really, really good question. Here's what we got. We have a whole nother hour here. If you're willing to stick around, then after I've demonstrated, kind of just making a really basic node program, the first thing we'll demonstrate is this whole async thing. So stick around. We'll actually get into this async and when you might want to use it kind of thing, okay? All right. Excellent. Welcome. And I'm going to mispronounce your name. I super apologize. Chibu Ike. I'm glad you're here. So what you're looking at looks super complex, Chibu Ike. This is just an example of a rather complex computer program written in JavaScript that provides information about customers and addresses and products and orders and that sort of thing. Okay. And we're just using it to at least demonstrate the basics that JavaScript functions, regardless of the syntax used to create them, sometimes take in parameters and sometimes don't. Now, here's the next question. Do functions always have to return something to the code that called them, to the part of the program that called on them? The answer is no, they do not always, they don't have to return anything. Sometimes there's work that you want done that all you need to know is that the work got done. You don't need any work product back at all. Like, for example, what if you wanted to capitalize every single entry in a big long list of names? You don't need the list of names back. You just need to know, did it get done with no errors? So you can make a function called capitalize, and it would literally pull in all the names in a list, capitalize every single one of them, saving each one as you go, and it was done. All the code that the part of the program that asked for that to be done, it just needs to know that you did the work. You don't have to send anything back to it. So as you're designing these functions, these repeatable chunks of code, the only thing that tells you whether it does or doesn't need parameters to come in, or whether it does or doesn't need to send something back to the part of program that called the function, is what your needs are. You're the one writing it. But you have that flexibility. And it will be obvious to you when you're trying to build one, whether it needs some parameters, whether it needs to be given information in order to do its job. And it'll be obvious whether or not, when it's done, it needs to send you back something. But you can build them either way. Good. So I want to do one other thing. I just want to run this program in a mode where I can stop it halfway through and just show you some things. Let's look at that. So right now I've got it running. I'm clicked down here in the console down below, the terminal, I mean, and I'm going to stop the server by hitting Control-C. Good, so it's not running. And now I want to run it, but I want to stop the program execution right here. So I put a little red dot there for a breakpoint. I'm going to go over here to run and debug. And let's see if it'll run. Good, debugger attached. That means there's a special program attached to my code. Okay, it's running some stuff here. Got some tests. All right, so this should be up and running, still on port 8080, but the difference is that oh, did it stop? Let's go to debug console. It might not have run. So this console here. Let's see if it's running. How can we tell? Well, we know that it's on port 8080. Let's go back to port 8080 here, and let's do a refresh. Ooh, look, it's running. It's not doing anything. Nope, it's not up and running. Good, so my debug isn't working, and I don't want to take a bunch of time with you guys in class to figure out why it isn't working. We can do the debug in our own program. So let's make our own program. Now, it's going to be a lot less complex than this, but I just want to stress what we're about to build. That's awesome, fire repeat. Exactly. All right, so we're going to build a very simple JavaScript program here, but bear in mind, this program is going to be able to run outside of the browser. It's going to just run on your computer because of the power of Node. So let's go back here to the terminal, and I'm going to go up one directory. I'm in my repos, and I'm going to make a directory called node_demo. And I'm going to change directory and go right inside that directory. So I'm now in my new directory here, okay? Just like with JavaScript programs that you're going to run in the browser, there's a little bit of housekeeping you need to set up in order to get your program to run. Here, we use a little tool called NPM. I've mentioned many times, it stands for Node Package Manager. And Node Package Manager can do some things for us related to our Node programs. The first thing we're going to do is a thing called Node Init. Stands for initialize. And it's going to create the one single file that describes some stuff about our project we're about to build. So you're going to see a lot of questions pop up here on the screen. So here's where I put the command in, right here. And then it says, this utility will walk you through creating a package.json file. Before we go any farther, let's explain what that is. Anybody in the chat want to take a crack at explaining what they think, what this package.json file is? Take your time, type it in. We're not in a hurry. It's okay. Good. It is some data, and it's in an object format, that JavaScript object notation. What does that data relate to? Oh, good. Shows your dependencies, general information. Awesome. Both answers are totally correct. We're going to look at some data. The format of that data is a thing called JSON, stands for JavaScript Object Notation. Well, what's this data all about? Well, it's about our project, specifically some things like, are there any dependencies? In other words, other code libraries that our program needs, for example. So let's just go through the questions it's going to ask. First, you're going to create a package. That's a collection of files and folders that make up your computer program, your application. What are you going to call that package? Well, by default, it calls it Node Demo because that's the name of the folder that I did everything in. That's a totally fine name for the package. So I'll just hit enter and take that default. What version am I starting this at? Honestly, the default of 1.0.0 is fine. I don't care about version, but you can designate this if you want to. What's the description? Test out some JavaScript coding for class. That's all this is for. You don't have to put anything, but I decided why not. Now, this is super important. For those of you who were in the class on Saturday that I covered the 5 basic elements of any computer program. I think some of you were here on the weekend. Can any of you recall some of those 5 basic elements of any computer program? Top. Excellent. Entrance point. What's the very first instruction? Good. Any others? These are 5 things that are necessary for realistically, any computer program. Oh, Chibuike, subprogram. Excellent. Let's go. I'll pick up that question in chat in just a moment. Subprogram. You rock. Good. Okay, so Chibuike asks, please can I get the recording of the previous classes? Yes, you can. I've got these cleaned up and they're out on YouTube. So let me go to, let me stop it so it doesn't play. Don't need it to play. I will put this in Twitch chat. So give me a moment. This is going to be fun. How do I do this on here? Something with control. Okay, I will get that link. Don't let me forget, Chibuike. I will get you the link. Here, just go to I explain technology. That's my I'm typing in chat. That's my YouTube channel name. So just look, I explain technology, and you'll see it on there. Okay. All right, good. So we're looking at the 5 basic elements of any computer program. We've thought of a top or an entrance point. Someone thought of programs, and then someone put in here something with control. I can't remember anything else. That's totally fine. You're totally spot on. What they are is control and, if I'm capitalizing, I might as well capitalize. Control and branching statements or instructions. Good. And sometimes I spelled branching correctly. Anything else? Oh, thank you for finding that leak, Sixth Season. I don't know how to pronounce usernames sometimes. I'm going Sixth Season. Bottom. Okay, good. Yeah. Bottom. What this is an exit point. Like, when is the program done running? Spot on. There's only one more. Remember what it is? Variables. Really hard to have a computer program without variables. So there they are. Okay. These are the 5 elements common to any computer program. Well, looky here in this really modern, ultra cool tool called Node. They want to know what the entry point is. They're specifically asking, what JavaScript file does Node need to look at to find the very first instruction to do? It's assuming that you're going to make a file called index.js. We can make it whatever we want. I'm going to call it main.js just to be different. Good. Okay, I'll just call you 6. Thanks, 6. Now, test command. I'm not going to get into that in great detail, but if you want to run tests, you can enter in a command here that'll be run from the command line to run a series of tests. A little more advanced, but it's kind of cool. I'm just going to hit enter because we're not going to have one. Ooh, a Git repository. In chat, please tell me if you do not know what Git is. It's okay. I just want to know. Don't feel silly for saying it. If you don't know what Git is, say, I don't. Okay, good. Excellent. Now, SJW, Git is a tool for accomplishing what's called version control. Now, people can get very complex and nerdy in trying to define or explain version control. But all it really is a program that helps you keep track of the versions of text documents. That's actually all it is. It's just a program to help keep track of the different versions there are of some text documents. Now, that's a pretty severe oversimplification because it is one of the key technologies we use to make software, and it is a pretty powerful little program. But when you think about Git, it's one example of a program for accomplishing version control, keeping track of and controlling the versions of different text files. The text files it works on are pretty important. They're our code, but that's all Git really is. So a repository is a collection of those text files. What it's asking for here is saying, hey, listen, do I need to look to an existing repository or a collection of text files to find the files for this project? Sometimes you already have that. We don't. So I'm just going to hit enter. Keywords. These are like tags. If I've got a huge number of projects on a computer and I want to search through them by keyword, let me list 2 or 3 or 4 keywords here. I've never really used this, but it's there. Author, super important. Put your name down, nothing wrong with that. Now, this is super nerdy. Software has different licensing requirements or different license types. There's a BSD, Berkeley Standard Distribution license, and there's ISC. I never even looked at what it was for. There's all kinds of licenses, and sometimes you might want that data to be there for the project so people who get a hold of your code know about the licensing requirements on it. This kind of thing's pretty important when it's important. For our purposes, we don't care. So I'm just going to hit enter. Now, it says, here's the last question it had. It's the license question. And now it says, about to write this to this location right here. The node demo folder that I just made into a file called package.json. It's confirming everything I just put. This is a JavaScript object notation object. It's a JSON object. It's composed of key value pairs. The key, for example, here is name. The value is node demo. The key here is version. The value is 1.0.0. Key here is main. Value is main.js, and so on and so forth. So, is that what I want? Yes. So I'm going to click Y for yes, and it made it. Now, if I go over here to my Explorer and click on it, oh, I need to open the actual correct folder. So I was in repos, and what did I call this thing? I called it node demo. Let me open node demo. And look, there I am, package.json. Now, I still don't have any JavaScript code to run. Well, Eric, this is a class you're going to run on JavaScript. Can we have some JavaScript to run? Well, yeah, we needed this package.json file first. This defines important things. What's the name of the project? A real important thing is when Node tries to run this computer program, where does it start? Well, we don't have a main.js file over here. And yet, this is where Node is going to look. So let's make one. Let's make a file here called main.js. Now we have a place we can put JavaScript code. Well, let's test that we've got everything working. Let's just do some sort of a simple JavaScript command here. We'll make a var. We'll call it foo. And it's equal to bar. And I want to print that to the console. I'm going to print the value of foo to the console. Now, where am I going to find my console? For those of you who've done web development. So I'm going to, let me ask this question first. Don't answer the other one. For when you do web development and you do console.log, where is the console that they're logging the information to? For web development, where is the console that information gets logged to? Yep, on the browser. 6 has got it right. You shipped your JavaScript code out to the browser, which means potentially your code is in millions of different browsers, millions of different users. They've got that code, they run the program. If something's going to print to the console, it's printing on their computer, in their browser, and they can go to developer tools. Let's pull up some. Let's see if we can go back here and see if, yeah, there it is. So here we are, we right click, we inspect, and we look over here to the console in the browser. Now I'm going to clear the console and I'm going to refresh. I'm going to run through all this code. Let me take away the breakpoint. Let's look at this console and watch. Run, And all this stuff appears in the console. Good. Anybody who's done any web development should be familiar with that. When you do a console.log, it's not something the user can see unless they're kind of savvy and they do the right click and inspect like we just did. Or in some other way, get to the developer tools. No, the console is there for you. Consoles are super valuable, but we're not writing code that's going to go to a browser. Our code is going to stay on a server. So let's look here again and say, if we've got console.log, where's the console? Well, thankfully, Visual Studio Code is kind enough to integrate with Node. Node does have a console. And so when we say console.log here, it'll actually get logged into the Node program. But because of the integration with this Visual Studio Code program, we get to see it down in our terminal. If we go terminal, new terminal, let's finally just run our program. We haven't run it yet. And it should log something to the console down here. How do you run it? You use that npm utility we talked about and do run a program, an instruction called start. I missed my start script. Oh, look at that. Good. There's some complexity here that I'm not going to add on for about 5 minutes. So let's go back. I'm not going to use npm start. We're not ready to yet. Instead, let's roll back. I called Node a runtime. I said that a runtime was a constantly running computer program ready to receive JavaScript code. And they could take that JavaScript code and execute it. And by execute it, I mean it can turn it into machine language that can run on my computer. So if Node's so awesome, how do I give it the JavaScript? Well, right from the command line, you just type node, and then you tell it what JavaScript file to run. Main.js. There it is. We're going to run it. And look at the output I get. I get the word bar right on the console. Why? Because I made a variable called foo. I gave it the value of the word bar, and then I did a console.log. All right, now that's not the most complex JavaScript code in the world. It wasn't meant to be. It's just meant to illustrate that I've got the basic building blocks of my Node program coming together. I'm able to actually start programming now because one, I have a package.json file that defines some fundamentals about my program. And two, I have a start point. And that start point has some code in it that I've verified will run. All right, so all that aside, now that we're capable of running some JavaScript and it's on my computer, it's not in the browser, it's running down on my computer just as if my computer was a web server of some sort. Let's practice some JavaScript stuff. One of the things that someone talked about earlier is asynchronous code. Now, for this one, I am going to return to a sketch that I did yesterday. And before I write a bit of code, okay? And then I'll show you when you might need something like this, when you might need to do what's called asynchronous. So let's stop sharing right here. And I'm going to switch over here. All right, so again, some of you may have been on the class on Saturday, and so this is going to be repetitious. I do recommend you pay attention. These fundamentals about computer programming is what I return to over and over and over again after all of these years when I'm trying to analyze either how to build my programs or what's sometimes more difficult, how to figure out someone else's program and how they were thinking when they built it. It always comes down in one form or another to some aspect of these fundamentals. We talked a bit about the 5 elements of a computer program: an entrance point, variables, control and branching instructions, sub-programs, and an exit point. Let's look at that sub-programs part. We said that you have what's called a path of execution. I don't know why I went green. So what I mean is the program goes from top to bottom, essentially. And you've got instructions, and we start at the top and we go to the bottom. But let's look at that a little more precisely. Here's an instruction. Another instruction, another instruction, another, and another, and then we're done. But over here is a series of instructions that we need to call quite often. And that is, well, we can call it a subprogram. In JavaScript, we call it a function. So, again, this is something we talked about on the weekend, but I want to reinforce it. Let's say we never used this at all. We never even used the subprogram. Our computer would start at the top here, and then go to the next instruction, and the next, and the next, and the next, and the next, and it would be done. It's not uncommon to write programs that are like that. They're called scripts. Happens a lot. But what happens a little more often is that we do, in fact, need to go from one to the next. And then we do need to use this subprogram. And when it's done, we want to come back right where we left off. And then we pick up again. And we keep on going where we were before. Now, all that's review. But sometimes the work that you're doing over here in the main path doesn't need to wait for this work to be done. The work in this subprogram. Sometimes we can go on a little bit, and whenever the subprogram is actually done, we can take whatever it was. Let's say this is the return object. We can take whatever it was that was meant to be returned, give it back to the main path, wherever we happen to be, and the program can make use of it. Now, this is all very abstract right now. I'm going to give you a real example in a moment. But let's review the two different scenarios. One, when we are moving slowly through a program, I say slowly, slowly for illustration purposes. Computers are awful fast. But when we're moving through a program, we can hit a point where we don't want to continue on until we call on a subprogram. It goes through and does all its work, and it returns either saying, I did my work, you can go on, or it sends an actual piece of data back and also says, I did my work, you can go on. And only then does the program keep going. That style of programming is called synchronous. Synchronous meaning occurring at the same time as. You're not trying to do two things at once, independent of one another. But sometimes you do want to do that. And when you do that, You can do programming that's called asynchronous. That's, you have one computing operation and a second computing operation. One of them is going on, and the other one can just sit there not doing anything, or it can go on, or it can stop and go on. And the two have nothing to do with each other. They're totally separate things. Now, again, this is really abstract. And the question in chat, which was a good one, was like, well, what's a real example? Here's a very real example. It's gonna be stupid and nerdy. Let's say that we're not actually calling a subprogram. Let's say the thing we're calling is some web service, but more precisely, it's all about the weather. And let's say if we send it a request for the current weather, it'll send back, I'm being very wishful here, 72 degrees. It's not 72 degrees here. Oh, that's right. We've got a viewer who's in England. I'm not, what is that? Is 72, is that 21 Celsius? I have no idea. It's like minus 32 divided by 9 or something like that. I don't know the formula. Anyway, this weather service, its job is simply to get a request for the weather and then send a response back. So let's say that our program over here is all about making an interface for our users. Like, let's say it's video editing software. It doesn't matter what it is. And we're starting up this program and we're like creating various elements of the user interface, and we're reaching down into the files and listing out all the different projects the person's been working on. And we can do each one of those things in order. But we also think it would be nice if up in the top right corner of the display, it shows the weather. I don't know why. Some marketing person got it in their head that our software should have that. And we fought them on it, and we only halfway won. And the battle was, or the way we won was, all right, we'll do it, but we're not going to wait to get that weather information before we put everything else on the screen. And they're like, okay, fine. So we build our program in this manner. We build it so that as we're going through the startup and showing all the various things on the screen, and we hit the point where we need the weather information, we just send a request to the web service that says, hey, can you give us the weather, please? I'm not going to wait for you. And we keep on going. The main path of execution keeps on going. But a tiny part of the program is sitting there waiting for this request. The rest of the program can go on. Now, how do you implement that under the hood? There's a lot of nerdy, geeky stuff I'm not going to get into in the scope of this class. But it can and does get done for lots of programming languages. So again, to reiterate, we're running through our consecutive instructions, and we hit the instruction that would say, hey, please obtain weather information. We send off a request to this service, and we designate a little teeny watcher waiting for the response. But meanwhile, we have another computing task. The main path of execution can keep on going. And when we finally do get that response, then we can use it to populate the weather. That means we have one computing task, our main path of execution, and a second computing task. This would be the weather request. And they are not tied together. They can operate at different times. That's why we call it asynchronous. So what's one of the most common use cases for this? Requesting work from something that's going to take a variable amount of time. We don't know how long it'll take to get the work done. Calls to different things out on the web are great examples, but also calls into databases are great examples because we don't know how long it's going to take to get the information from the database. It might be that no one else is accessing the database and it comes back super fast. It might be that that database is literally on the other side of the world because someone didn't know how to design the system. And it has 10 million users on it right now, and it takes 3 minutes to get the information back. All of these things are possible. The point is, you don't want to keep the rest of your program, at least the parts of it that aren't dependent on that service being done. You don't want to keep the rest of the elements of your program waiting. So don't make this entire segment of work, make this yellow, make this whole segment of work all be asynchronous. Everything involving requesting and receiving the product of this work, the product of this service, I mean, all of it's asynchronous. The rest of it is synchronous. Keep on going as you will. Move to the next step and the next step to the next. And if you get all done, fine, you're done, but you're still waiting for this information and you'll use it when you get it. That's asynchronous, and that's a few different use cases of when you might want to do it. So let me stop sharing. Actually, I think I can switch on here. So I'm looking at the chat, and I know that it was fire repeat. You still on? If not, that's fine. I hope that helped explain async. Now, here's what makes it complex about JavaScript is there's like 3 different ways to do it, which isn't fair. I'm not going to do a big old coding example with all 3 different ways to do it, but I just want you to understand what the different variations are. Like, oh, sorry, what the use cases are, why you might ever want to do something that's called asynchronous. Now, let me share my screen again because I always forget. And let me look at chat again. Awesome, fire repeat, you're still here. I hope that helped. I'm glad you're still here. And that was a very, very good question. Now, I'm working on a little code demo for a whole separate project that will simulate a real world situation when you might want to call on something that just takes a little while to get an answer back, to get the work done. So you can see asynchronous calls in action. I don't have that all configured right now, or I pull it up on the screen and give you a demo of it. Okay, good. All right, so now I'm going to open it up. We've got a few viewers left, and thank you for sticking with us. I appreciate it. What are some elements, some other elements of either programming in general or JavaScript that you'd like to see coded out or explained? Yeah, Fire Repeat says, yes, I found myself jumping around between Fetch, Axios, and trying to use MongoDB. Too scattered. Okay, good. So let's explain a bit about what those things are. Oh, this will be fun. I am going to get into a little bit of nerdiness involving making web requests here. Can anyone tell me in the chat what HTTP stands for? HTTP? It stands for Hypertext Transfer Protocol. Good, I got hypertext. Good job, SJW. Hypertext Transfer Protocol. All right, so no problem, Rund. So this is something we were talking about on Saturday. I talked about the difference between the internet and the web. The internet is a big collection of networked computers around the planet and a set of agreements about how to transfer information between the computers. Those agreements about how to exchange information are called protocols. And there's lots of different protocols that have been created over the years. Why? Because there's lots of different types of information. There's banking information. There's healthcare information. There's audio file information, video file information, and there's web page file information. That's the one we're concerned with a lot as web developers, obviously. So what's the agreement or protocol that describes how to exchange these web pages called? Hypertext Transfer Protocol. Why? Web pages are written in hypertext markup language, and this protocol is about transferring them back and forth. Hypertext Transfer Protocol. Good. So the principle is pretty simple. Let's stop sharing them for a second. Go back over here. I had this little sketch before of you've got somebody's PC. Here he is. This is Bob in Topeka, Kansas. He has a PC, and on this PC is a browser. I said that over here is a web server. It's also just a computer. I put PC just to say it's a computer, not a personal computer. It's a pretty beefy computer, but it's a web server. Now it's got a specialized computer program on it. It's called Web Server Software. Now, the interesting thing is there's really only, it's really horrible writing. There's really only like 4 popular pieces of software in the whole world used here. They are Apache, HTTP server is what it's called, Apache. A thing called Nginx, Nginx. Something from Microsoft called Internet Information Services. And then Node. That's really it. There's like 4 popular web server softwares in the whole world. I think that's kind of cool. It doesn't matter. The point is, the browser said, hey, I want a specific web page. It sends off to the web server a request. This is what we're going to look at, is the request. The web server says, oh, well, I know what you need. You need this file and this file and this video file and this image. You need all this stuff. I'm going to send it back. That's the response. Well, these request and response documents, you're going to work with these all the time as a web developer. So you need to know something really cool about them. All they are is text documents. There's nothing magical here. It's just text. That's all it is. I'm going to show you one in just a moment. Go ahead and stop sharing. Start sharing on mine. Let's pull up that project I had before, which was the API that was running. This is back-end thing here. Let's enlarge that. So I have this computer program right here, and come on, terminal, you can come up. Good. Let me go ahead and start it up again. npm start. It's running. Okay, good. Now, I have a little utility installed inside my Visual Studio Code that can take one of these HTTP requests. Sounds all fancy, it's not. They can take one of these requests and it can send it to my running computer program. My running computer program is on port 8080. You can see it right here. I already demonstrated that. Showed you again here. If I go to localhost and go to port 8080, I can go to /API/products and it'll send back all this information. But let's see what is actually being sent to get that information. If I go back to Visual Studio Code here, I've got this cool little file here, or collection of files, HTTP. This is just text files. Let's look at the products one. Look what I have right here at the very top. I know it's color-coded for readability, but it's just text. And because I have a little utility installed in Visual Studio Code, it lets me, if I click on this thing right here, send this text to port 8080. That's all it does. It just sends it. And it's just text. There's no magic to it at all. If this exact text, specifically /API/products, arrives at the server that's located right here on port 8080. And if it arrives with the word get, then my computer program knows what to do with it. Let's send it. And off on the right here, this is the response. This again is an HTTP response. It's just text. Again, there's no magic to it at all. It's just text. Now, again, it's color-coded for readability, but all I got back was text. Makes it super easy to work with. Here's the text that shows this big collection of products. Well, that's not the only kind of thing I would want to have happen. I just requested a list of all the products. What if, for example, I wanted a specific product? I wanted product with an ID of 22. I send this text right here. Literally, this text gets sent to the server. Let me send it. And look what I get back as a response. Oh, I erased my slash. Let's send it. I get back item number 22, handcrafted steel salad. I used a computer program that randomizes English words. I love it so much. Handcrafted steel salad. Good. So these things that you're looking at here, line 14, line 7, line 4, those are HTTP requests. Now, they can get a little more complex. Let's look at one for, say, addresses. Here's one to get addresses. Let's look at see if that works. Oh, look, I got a bunch of addresses. And here's one to, let's get a specific address. Let's do /2. We'll get address number 2. Let's see if that'll work. Look at that, I got address number 2. But what if I want to create an address? Look at that, create new address. This is just a comment right here, line 27. Line 28 through 37 is an HTTP request designed to create something. If I send it in and it's properly formatted with what part of the program to send it to, what kind of operation to do, post involves creating things, and the information needed to do its job, it'll do its job. If I send this in, it should make an address for me. Let's change it a little bit. Point place, I can put it Point Boulevard. And let's hit send. Look at that. It made a new address with an ID of 104 and put it into the database for me. The reason I just want to show you this is because when you're trying to learn all these technologies at once, and there's a bunch of stuff going on, knowing the simplicity of what's under the hood can be really, really helpful. Remember that diagram I drew on the iPad? The simplicity of what's occurring is that a browser is sending a properly formatted request, and it's just text. If it arrives at a web server and gets routed to the right section of the code, then that code can compose a response, an HTTP response, which is, look over on the right here, it's just text. That gets sent back to the browser that asked for it, and the browser can use it to do what it's programmed to do. And that's how this system works under the hood. Now, what we're looking at in this big program here on the left is a program written in JavaScript that lets me create, read, update, and delete all four of these things over here: products, orders, customers, and addresses. And that's the kind of thing you can learn how to build, but you need to know the underpinnings, what's underneath the hood. All right, let me go back to viewers. All right, is the main difference between fetch and XML HTTP request is you can use promises with fetch. Okay, that's a very good question. So now, having described all that, and we'll wrap up here in about 3 minutes because I said we're going to go till 9:30 my time. What Fire Repeat is asking about is when he says in the chat, I found myself jumping around between fetch, Axios, trying to use MongoDB, and then he says, is the main difference between fetch and XML HTTP request is you can use promises with fetch. Here's the whole swirling of terms he's talking about is what I just showed you about HTTP requests and responses has nothing to do with any programming language. This is the agreement that was arranged over the last 30 years on how do we send HTTP data, hypertext, web page data back and forth. What he's asking about, and it's a great question, is are there libraries or functions inside of JavaScript that will help me make these requests? And the answer is yes. The first library from way back when JavaScript was first coming about so we do JavaScript libraries or functions for working with HTTP requests/responses. The first one was XML HTTP request. This was old school, like 1990s. I feel so old. I'm not going to get into the difference between all of these. The next one that came along, and let me clarify here, built into JavaScript, came with the language. Next one is fetch and improvement. And this is the 2000s. They came out roughly. And same thing, built, that's supposed to be built into JavaScript. But I think about 10 years ago came Axios. It's awesome. This is Eric's opinion only. Not built into JavaScript. So that's some orientation to kind of explain those terms that he was using. Okay. And now we can discuss pros and cons between them. So you'll only find this old school function for making, working with HTTP requests and responses in pretty old JavaScript code. It still works. And when I say works, I mean that most browsers still support it. Okay. You'll find fetch working in almost every browser. Axios doesn't come as part of the default language. So browsers aren't going to automatically have it. You have to put it into your project. You have to literally go out to Axios download, go out here to this big collection of JavaScript code called NPM repository, find this one called Axios, and install it, like literally download it and put it into your project. And when you do that, now you have access to the functions in this Axios library. Good, so that's some orientation. Now, there are a lot of differences between all of these. I'm now going to read what he was talking about. Is the main difference between fetch and XML HTTP request is that you use promises with fetch. I forget. It's been a little while since I looked at this. So let's just look. I like this because now we have enough context to understand the question. So difference between fetch and XML. See, look at that. I didn't have to type it out. Yes, there it is. Promises are one of the three ways of handling that asynchronous stuff in JavaScript that I talked about. That's a subject for a whole nother class or presentation, okay? But yeah, that's really the big difference. And again, there's nothing really horrible about XML HTTP request, except that it's really not a lot of fun to type out. But yeah, as the JavaScript language evolved and started to use these things called promises for asynchronous coding, the people that maintain JavaScript didn't make XML HTTP request, which is all old school, conform to that new promises system. So yeah, that's the biggest difference. That was a good question. Okay, good. All right, we could go on for a while. I'm 2 minutes over. Just like Saturday, what I super appreciate is insightful questions, good feedback, and most importantly, even though we're doing this in a weird way, because all there is chat, you guys are involved. You jump in, you answer, you give me feedback, and I really, really appreciate it. So thank you all for doing that. I don't know that I'm going to do that many more of these just off the cuff sessions, because I'm putting my efforts into the launching of 5 Live Code School, which will be a full, complete curriculum for a coding boot camp. I formed one of the first coding boot camps in the entire country back in 2013. I know my way around a boot camp, and I'm going to put on a really good one. The only catch is there's only 5 students allowed live inside the classes. Everybody else has to watch from the outside. So if you're interested in that, go to my Twitter at Eric David Gross. I'll put it inside here. That's my handle on Twitter. And I've pinned the post that details, I put an FAQ up about the actual school. I'd love to see some of you there. I will do, like I said, periodic, just off the cuff stuff that I really want to experiment with. Who is it that was interested in the MERN stack? Is that you, Fire Repeat? Okay, good. Yeah. Here's what I'd like to do, actually. I'm going to give you an invitation, Fire Repeat, if you want to. What I'd like to do is you jump on a Zoom call with me, and we build a MERN app from the beginning to the end, even if it takes a couple, 3 sessions, and we just do it online, and it becomes one of these videos that people refer to later on. Is that something you'd be down with? Awesome. Okay. Go ahead and find me on Twitter and send me a DM. We'll get in contact, and I've wanted to do one of those for a little while anyway. And it's a lot more fun when you've got someone that you can bounce things off of and actually have a live conversation as well. So get a hold of me. Folks, thank you so much for tuning in. I appreciate it. Look for information about 5 Live Free Code School coming up, and especially check out the FAQ, because I put a lot of work over the last few days into it going from just a silly idea to a very real, concrete, organized form. And I want feedback, and I'd love to see you guys involved. Thanks all. Have a great evening. Signing off. You're welcome. Thanks, SJ. Oh, Marco Hartz. The place to get information about the school is go to Twitter. Eric David Gross on Twitter. Remember, it's ERIK. Eric David Gross on Twitter. And the pinned post has the FAQs. That's where you can find information about it.